So this project consists in solving a problem that may be presented in daily life using math operations such as the simple harmonic motion and all of its derivatives. The main objective of this is to put in practice all that has been seen during the semester, such as graphing an equation and seeing the parts of the graph. In order to understand a little bit more about this project, it is important to know some key concepts that will help solve this problem, and this will be seen next. This is the main concept to understand, and the simple harmonic motion can be defined as a repetitive movement that goes back and forth and goes through a central position, meaning that the maximum displacement of one side will be the same in the other side. The period of a wave is defined as the time that it takes a particle to complete a vibrational cycle. It is mainly measured in time units, for example, seconds, hours, etc. The frequency is defined as how often the particle vibrates when the wave passes through the medium. The amplitude of a wave is defined as the maximum amount of displacement of a particle on the medium to the rest of the position.
The problem I was assigned says, each time your heart beats, your arterial pressure increases, then decreases for your heart rest between beats. The arterial pressure of a person is determined by the function Pt equals 115 plus 25 sine times 160 pi t, where Pt is measured in mercury millimeters and T is measured in minutes. The first that is required is to find amplitude. Amplitude is determined by the number before sine or cosine function. So in this case, amplitude is 25. Now, period is determined by the formula 2p over w. In this case, w is 160 pi. So it will be written as 2 pi over 160 pi. As it cancels and then it can be simplified, it's 1 over 8. The frequency, the formula is the inverse of period, so it's w over 2 pi. In this case, it will be written as 160 pi over 2p. Same, it cancels, it can be simplified as 80. First, to start making the graph, it is important to see if there is an elevation or not. And yes, as our formula indicates, it will elevate 115. So, as the time cannot be measured in negative numbers, the first point will be in here, 115, and in this axis. Next thing to do is to identify that the sine graph is positive. So it will go first up and then we'll go down. And then to orientate more, we will start marking our points. So the period is 1 over 80. It indicates that it will end our first sine in 1 over 80. Then to be more orientated, we can mark a point in the middle here. And then we start doing our curves, taking consideration not to pass 140 and 90 because the amplitude is 25. So it goes up, then down, like this. And as indicates a heartbeat, it cannot only end here, so it continues the graph. We mark again. And we indicate it continues. Finally, it goes question C that says, if a person is doing exercise, your heart beats faster. So how will this affect the period and the frequency be? It's easy. If a heart starts beating quicker, it will be more times in a certain amount of time. Meaning mathematically that if the period is smaller, this makes that the frequency increases.
The simple harmonic motion is very useful as it can be used in daily life problems, for example, as we seen with the beating of a heart, but it has other applications in the daily life too. For example, when you play some music, it generates waves that obviously it can't be seen, but it can be plasmated in an equation and later on be graphed, all thanks to the simple harmonic motions. And in the same graph, we can analyze the period, the frequency, the amplitude of the waves, etc. As a conclusion of the project, the simple harmonic motion is very useful in daily life problems. For example, as we saw in the problem to calculate the beating of a heart. And yes, although this problem may be seen in an algebraic equation with some numbers, the simple harmonic motion helps to see more visually the problem. By graphing it with sine or cosine, we can make a more clear idea of the problem that we have and see, for example, the amplitude, the period, or the frequency of this.